Good morning, everyone, and welcome to the December edition of the Southeast Climate Monthly webinar, where we talk about climate and special topics pertaining to the Southeast region. I'm Sandra Rain, the Regional Climatologist from the Southeast Regional Climate Center, and I'll be giving a climate overview. Our guest speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources overview, Pam Knox from the University of Georgia, who will give an agricultural impact update, and our special topic speaker, Michelle LaRue from NOAA's Climate Prediction Center, who will talk about the La Niña Outlook. We thank them all for joining us. Just a reminder before we begin, type your questions in the question box at any time and they will be answered at the end. Also, a recap email with a YouTube link to this recording will be sent out in the next day or two. Okay, let's talk about the climate. Temperatures over the past 30 days have been near average across most of the region, but above average in the Caribbean. As a matter of fact, San Juan, Puerto Rico actually tied for its second warmest November on record. Precipitation over the past 30 days has been almost non-existent. It's been quite dry out there. In some places, almost 3 to 4 inches below normal. Danville, Virginia, and Hickory, North Carolina both reported their driest November on record. But what does that mean for the entire season? Well, for most of the region, temperatures have been near average, with much of Virginia and parts of North Carolina seeing slightly above average temperatures. This was due to a near average September with a fairly warm October and a cooler November to follow. Despite the significant rainfall over the summer, precipitation this autumn was below normal for much of the region. However, for much of the region, October and November are climatologically one of the drier times of the year. We also did not see very much severe weather either. Typically, we have about 200 reports of severe weather for the season, but this year we saw just half of that. Normally, we receive around 36 tornadoes, and this year we only had 1 confirmed tornado. The entire month of November, we only had 2 reports of severe weather, which is unusual considering we typically see a slight increase in severe activity during the autumn months. One of the many reasons for this is that we didn't see very much tropical activity these past few months. That's not to say it wasn't an active season. We did go through the entire list of names this year. The season officially ended on November 30th with 21 named tropical storms, 7 of which were hurricanes with winds of 74 miles per hour or greater, and 4 of those were major hurricanes with winds of 111 miles per hour or greater. This year was the 3rd most active year on record in terms of named storms and the 6th consecutive above normal year. This was also the first time on record that 2 consecutive hurricane seasons used up all 21 of the storm names. As always, NOAA continues its hurricane research and observations, and this was the first year that an uncrewed sail drone captured video and measurements at the surface of the ocean during a major hurricane, withstanding winds of 120 miles per hour and 50-foot waves during Hurricane Sam. So it has been a very interesting tropical season. Moving on to the ENSO update, I'll keep it short since it's our special topic for today, and mention that we are under a La Niña advisory with a 95% chance of La Niña continuing through the winter and a 60% chance of a transition to ENSO Neutral during the spring, April through June. The U.S. Drought Monitor still shows some exceptional drought in the western part of the United States, but hopefully some of that will continue to improve this winter. Here in the Southeast, the lack of precipitation has led to severe drought conditions in parts of Virginia and the Carolinas, as well as abnormally dry conditions much elsewhere, except the Florida Peninsula. Moderate drought has increased across Puerto Rico, with extreme drought developing in parts of the Virgin Islands. And unfortunately, this is expected to persist and even expand throughout the region over the next month. For the next 3 months, we have the probability of seeing above normal temperatures across the region, with the probability of drier conditions in the southern part of the region and the probability of equal chances of wetter or drier conditions to the northern part. This is a typical La Niña pattern. For the December 18th to 22nd outlook, There's a probability of above average temperatures and the probability of above average precipitation. Hopefully we'll see some rain. But will it be a white Christmas? The outlook isn't very great. It looks like we have the probability of above average precipitation, but unfortunately, it also looks like we have the probability of above average temperatures, so it might be a rainy Christmas. Speaking of rain, it doesn't look like we'll see very much through Saturday. However, it looks like our best chance of rain comes next Monday. It doesn't look like much, but any little bit will help with some of the dryness. To sum up, the Southeast has had near average temperatures and below average precipitation. Tropical season has officially ended with 21 named storms. We are under a La Niña advisory. Severe drought is in parts of Virginia and the Carolinas. And Puerto Rico has moderate drought. Our next system and best chance of precipitation comes around Monday, and the next 3 months will likely be warm and relatively dry. And now I'll send it on over to Jeff with the water resources update.
Okay, thank you, Sandra. And we'll talk about our winter outlook here as well as the stream flows. And as Sandra pointed out, the dry weather continues for a lot of the Southeast, and that is showing its reflections in the stream flows. The severe drought that she showed in the Carolinas, showing up in our stream flows here in the Carolinas here, North Carolina and South Carolina. You can see those orange in parts of Southern Virginia. You can see those orange dots. That means that they're below normal across this part of the region, and near normal elsewhere. But as overall, the 28-day average hydrograph for the stream flows, you can see we've really taken a dive here from the middle part of October when we saw a lot of the river flooding and high stream flows. We've taken a pretty good drop here as we head into the middle part of December here, and we're just on the fringe of the near normal and below normal. This is typically a time period when we start our primary recharge period. So we typically start to see stream flows on the rise, as well as we start to get into some river flooding across the region. We'll go to the next slide, breaking it down state by state here. And you can see the 28-day average stream flow or runoff hydrographs, as we call them, from the U.S. Geological Survey. For Alabama, again, you see the pretty good drop there from the summertime, well above normal stream flow periods through the early part of the fall. But the late part of the autumn here has been dry, and we're seeing that as far as the stream flows falling into the normal range. And we sort of brought this up in the last call that we would probably see this fall into the normal range. But now some of these, you're seeing them tread into the below normal range at a time period when stream flows, again, are typically start to rise. So Georgia, same thing here. The signals are pretty similar for Alabama, Georgia, and Florida, all in the near normal range, but with this trend toward below normal. We go to the next slide, and now we go into the Carolinas here, South Carolina, North Carolina, and Virginia. And we can see, whereas the western part of the Southeast region was in that above normal range with the drier weather anticipated for November and in December, where we saw that fall into normal range, the Carolinas were more in the normal range for that late summer and early autumn period. And so we're seeing stream flows in that region fall now into the below normal range. And you can see there for all three states. We'll go on to the next slide. And so this will follow up. Michelle will talk more about La Nina, but these are, this is basically the map on the left here is December stream flow analogs from 1950 to 2010 for the entire region at the Huck 6 level. And you can see typically with La Ninas, we have stream flows that the probabilities, you can see the little small pie charts there, are generally greatest for below normal stream flows. Again, it's not always the case where we have La Nina and below normal stream flows, because you do see part of the pie there and the green and yellow, meaning above and near normal. But for the most part, the little pie charts down there across the southeast show a greater part of the pie is in the red, meaning below normal. Most seasons, when we have La Nina for the month of December, we see below normal stream flows. And so we look on the map to the right here, and we see that is the case across most of the mid-Atlantic, looking at the last 28-day average stream flows. And for the most part, we see the sort of somewhat similar pattern. To me, it almost looks like the axes are just a little bit a little bit farther north than what we see typically. Again, you can see there in parts of Arkansas, they're also experiencing below normal stream flow. And so these two pockets that you see on the left there across western Texas in the southeast, they're almost like they're shifted a little bit farther north. And so that'll be interesting to see watch as we evolve and as we move into the winter, January and February months. And so the next slide I've got here is the January stream flow analog, and we see again very similar pattern here. Most of the probabilities are for, especially across the Florida Peninsula, are for stream flows to be in the below normal range. And then we go to the next slide here. Again, we see as well in February, most of the southeast, very similar to the CPC outlooks. Well, the February's probably may have one of the strongest signals. So generally, the analogs show maybe a strengthening as far as stream flows. And this might be a little bit of the latency of dry weather in the latency in the stream flows that the dry weather in the early part of the winter, we also see the effects of stream flows late in the winter. Sort of what we're seeing, and also indicates maybe a little bit of strengthening and maybe a higher probability of below normal stream flows as we go in the middle to later part of the winter time period. So we'll go on to the next slide. And we can see right now, typically this time of year, we start to see river flooding across the southeast by mid-December, mid to late December. But right now, most of the stream flows are pretty calm, and we've been calm really for the last couple of weeks. For our office has been nice. No flooding across the southeast, and we'll go to the next slide. And we can see we're in week 50 of the year, and for the most part, the flood climatology does show that signal, signal of increasing flood events, in both flood events in magnitude, typically in magnitude, and in the extent of coverage. We usually see across the southeast a pickup, but not this year, which again has been nice because we were talking yesterday in the office. The past several Decembers, even the La Nina one we had last year, were very active. Go on to the next slide. And so overall, for the winter flood outlook for the winter period, we're going to call for below the typical flooding across most of the southeast. The December has begun this winter, typically is our winter recharge period, and we expect river floods this time of year into January, February, and March. And even though we will see some flooding, I don't think it'll be to the extent that we typically see it. This doesn't mean that we're not going to see river flooding. It just means that the extent and the magnitude will be less than the typical season. This is based on La Nina and then just the current trends and the outlooks from CPC. So that's sort of what we're looking at as far as the river flood outlook and stream flow outlook. So in summary, if we go to the next slide here, again, stream flows, they continue to generally fall across most of the region with the drier weather, especially across the Carolinas. And with the dry weather, we're going to continue to see the lower stream flows. And these are, as we showed in the analogs, this is pretty typical with La Nina. And then December, typically we do begin the flood season. And so flooding won't be out of the question. We'll see some floods across the region through the winter period, but just not to the extent and magnitude. And, you know, we will probably see some water resources becoming more of an issue, especially across the Carolinas as we go into the late winter. And this could become more of a concern, especially if this lingers into the early spring. We'll see probably some reservoirs that will have issues with potentially meeting their target pools. So the good news is less flooding. The bad news is maybe water resource issues as we go into the late winter and early spring. And that's all I had as far as the water stream flows. And now I will pass it on to Pam.
Well, thank you, Jeff, and good morning, everybody. I'm glad to be here. I'm wearing my Christmas cow sweater today, but I'm on the phone, so I can't show it to you. So you'll just have to imagine it. I'm going to talk for just a few minutes about agricultural impacts. I want to leave plenty of time for Michelle because I know she has a lot to say. You've seen some of these before. We've been relatively warm for the last month and very dry across most of the region, and so we've had an expansion in the drought. I did put the soil moisture map here from earlier this week. It does show the rain that we had over the weekend, so that's why things are relatively wet in Alabama and Georgia. Probably won't last too long. And just look at how dry it is in the Carolinas and Virginia. And so it's no wonder that they've been having a lot of problems with drought. If we go on, here's some of the impacts of the recent conditions on agriculture. Most farmers are just finishing up their harvest if they haven't already. Not a lot left to do with that regard. And there's been a lot of frost. I'll show a map in just a minute that shows where the growing season has ended, but a lot of it is ended for the southeast, as you can imagine, except for Florida, of course, and along the coast, where it's been a little bit warmer. The dry conditions have been good for the crops that are there because they're not really seeing a lot of disease pressure because of the low humidities. And because we have had these warm temperatures in the last week or two, the strawberries that have been planted in the warmer areas in South Carolina, at least, have really started to develop quickly, which the farmers are happy for because they were kind of being pokey with the cooler temperatures earlier in the year. In Georgia, of course, our Vidalia onions are getting planted right now, and they're really ahead of schedule because it's been so dry. They've been able to get out in the fields every day. So that's been really good. If you look at the harvest, it's still a little behind the 5-year average. So they're still playing catch up with that. And so not surprising there. They are doing some irrigation of the small grains due to lack of rain in the areas that are dry. And then if you look down in Florida, they haven't been affected, of course, by frost yet. They've had a little bit more rain. So the citrus crop there is progressing pretty much as normal. Things are looking good there. And of course, a lot of that is irrigated as well. If we go on to the next picture, next slide. Okay, there we go. The end of the growing season. This is a map from the Midwest Regional Climate Center of the date of the first 28-degree Fahrenheit freeze, which is, of course, the killing frost. And you can see that most of the region has had killing frost, with the exception of Florida, except for a little bit in the panhandle there. And the southern part of Georgia, southern part of Alabama, has not really seen killing frost yet. And that's pretty typical for this time of year. They may not see it for another week or so because it's going to be relatively warm, but it's coming, as we expect sooner or later. If you want to see updates of those, you can go to the website that's listed there on the bottom. Meredith will probably put that in the summary. If we go on. I've been getting asked by blueberry and peach producers about chill hours for our fruit crops. And this is a tool that the agroclimate from agroclimate.org, which is run by the University of Florida. This one is for Peach County, Georgia, which is just a little bit south of Macon, so near the center of Georgia. Shows this year's accumulation is almost the same as last year's, but both of them are below the long-term average for chill hours. And the projections based on La Niña, which we're in right now, show that there's still a wide range of possibilities. We know for the next week or so it's going to be pretty warm, and so we won't see a lot of chill hour accumulation there. But after that, it should pick up a bit. I did put on the bottom there the comparison between the average number of chill hours for neutral, El Nino, and La Nina years, and it's really not that big. There's so much year-to-year variation that even with the differences in neutral, El Nino, and La Nina temperatures, the chill hours turn out to not be, on the average, that much different. Although, again, like I said, from year to year, a big variation. If we go on, rainfall across the region, of course, Sandra already showed this a little bit. The dry conditions in most of the region are going to probably explain drought in the next map. Most of the rain that we do see coming is going to be late in the week, so we don't expect to see a lot here. Next week's going to be quite warm for most of the region. Slight edge to the wetter than normal conditions, as Sandra pointed out. And it looks like for the rest of the month, it'll be on the average warmer than normal, but it does look like there's going to be a change in the pattern after about the next 7 days. And so we may see some cooler temperatures, a little bit more seasonal by the end of the month. If we go on, some of the threats to agriculture in the coming weeks. Of course, the tropical season is probably done. Don't really expect to see any more this time of year. Dry conditions are going to continue to expand the drought. Probably wetter conditions by the end of the month. Whether it's going to be enough to make a change in drought status, of course, is still up in the air, and the La Nina will affect the weather over the next few months. This is a experimental map from the Climate Prediction Center that shows the drought tendency forecast, and you can see that it shows drought expanding into perhaps northern Florida and more of Georgia, and getting much worse in the eastern Carolinas based on the short to midterm predictions. And so that's something that we're going to have to continue to watch over time. If we go on, this is a summary of the ag impacts. The dry weeks have really helped farmers catch up on their field work and harvest, and have been able to plant their winter crops like onions at great speed. The increase of dry conditions is a little bit alarming, but there's not a lot growing right now except in Florida and right along the coast, and so it's not a real major threat to crops at this point, but it's something we're going to be watching going into the next growing season. Frost has ended growing conditions for the northern areas. We probably won't see any frost in the southern areas for at least the next week or two. After that, of course, we're in winter, so you're going to see cold temperatures at some point. Chill hours are below normal, and that's expected to continue. And we'll be watching that to see what happens. If we don't get enough chill hours over the winter months, the plants don't really settle out of blossoms. They get confused. They'd like to have that cold weather so they know when it's time to bloom. So that could be one consideration. If we do have enough chill hours over the winter and things are warm in the spring, we could see early blooms, and that makes them a lot, of course, more susceptible to any late frost. So that's another thing we'll be watching. And then, of course, La Nina will continue, and that will have impacts as well. It's not unlikely for us to go into a drought the summer after a La Nina. So that's something we're going to be watching. Way too early to call that yet, but it's just something to keep in mind. And so with that, I will stop my presentation. I will pass it on to Michelle. I'm really looking forward to hearing from her.
All right. Thanks so much. Those are some great presentations. You'll definitely notice a little bit of redundancy, but redundancy in my mind is pretty good. That helps when I see things several times. Anyway, so hopefully I'll be able to give you kind of bird's eye overlook of what ENSO is, and also touch on our seasonal outlooks. And so right now, NOAA Climate Prediction Center is in a La Nina advisory. We have this entire classification system for both the warming of the tropical Pacific Ocean, which is our El Nino, and then a cooling of the tropical Pacific Ocean, which is La Nina. And we put out a watch, I think back in like June or July, transitioned to an advisory a couple months ago. So everything's been progressing pretty much as we expected starting this past summer. And so the most recent update, which was created last week, so this is pretty fresh information, is that La Nina is favored to continue through the winter. There's a 95% chance of that, so extremely likely. And then we expect a transition to ENSO Neutral, and ENSO Neutral is just sort of in between category of, it basically means the tropical Pacific Ocean is normal. And so we expect things to transition away from La Nina and toward neutral during the spring. And we favor neutral or these normal conditions during starting in the April, May, June period. So neutral in the tropical Pacific looks a lot like this diagram in the top left panel here. And so this is what you would typically expect when you average together a lot of data over many decades in the tropical Pacific. And that is, you would see warmer waters in the western Pacific and cooler waters in the eastern equatorial Pacific. And as a result of this temperature gradient or difference, you see winds blowing at low levels from east to west. These are our low-level easterly winds. And since we have warmer waters over Indonesia, you tend to have more rising motion and convection in that zone. And over the cooler waters of the eastern Pacific, you have more sinking motion. This is called the Walker circulation. So ENSO is interesting because it's not just one variable. It's really the interplay of both the ocean and the atmosphere. So we, even though we often emphasize ocean-based indices, we also keep an eye on these atmospheric indices as well, because it is the coupling and connection between the two that gives rise to El Niño and La Niña. And so La Nina is basically, it's pretty easy to describe because it's basically that normal pattern except juiced up. So La Nina is an amplification of the neutral state, and we see more convection than average over Indonesia, more sinking motion over the eastern Pacific. As a result of the enhanced trade winds and easterlies in that zone, we see cooling in the eastern Pacific. And this is all coupled through mechanisms that I won't get into detail here, but there is a ENSO blog post that does describe this feedback and this mechanism. So if you are interested in this, please check that out. So what do the sea surface temperatures look like over the last month? So this is the monthly average for November. And this is one of the prettier pictures that comes from climate.gov. And it shows the equator in the tropical Pacific, and there's a lot of blues there, and the blues indicate below average sea surface temperatures, a very kind of classical depiction of La Nina. And you may be experiencing some deja vu because this is the second winter in a row where we've had a La Nina. And it's not entirely surprising to see back-to-back winters of La Nina. This is showing a measure in the east central tropical Pacific. It's not that important exactly where it is, but it's a measure of ENSO. And so the y-axis is essentially this index, the Niño 3.4 index, and it's showing the temporal evolution over time of this particular index. And when the index is greater than this 0.5 degrees centigrade, then we loosely would call it an El Nino. And when it's cooler, as you can see there, minus 0.5 degrees centigrade, that's our La Nina threshold. So when values are below that, we typically call that La Nina. So what you see is that blue line is our current La Nina, and the first winter is evident there in 2020, 2021. And now we're essentially entering the second dip of that. What you see is the average, which is that dark black line. So this is taking all the past La Ninas that we've had since 1950 and averaging together. And what's really interesting is really since last winter, the evolution very closely adheres to that average pattern. Typically, not always, the second dip is a little bit weaker than the first dip, and that is what we're seeing right now. So if you were to take the Niño 3.4 index values, this kind of temperature data set, which is useful to us because it is a historical reconstruction, so we can track it all the way back to 1950 and then rank how cool the values are. And so they're sorted here by the coldest values in this particular index, showing the top 15 winners of the 70 or so that we have. And 2021, our most recent period, September, October, November, is there at the bottom, so it's ranked 15th. And showing last winter, 2020 is also there. As you see at this time, it was actually a little bit stronger. But keep in mind the strength is only relevant to the tropical Pacific. It doesn't necessarily mean that the impacts on the US are also going to be weaker. So it's very important when you communicate to your users that yes, we can tell you how strong La Niñas are relative to each other based on tropical Pacific metrics, but that doesn't necessarily mean that you'll see subsequent intensity on the extratropics and North America. Also, it's important to emphasize that La Niña isn't just sea surface temperatures. We have a really long, nice record of sea surface temperatures, which is one of the reasons we use it. But there's a lot of atmospheric measures too, and they're not necessarily always, in the same sequence in terms of ranking. So this is another measure. This is below the surface of the ocean. So it's basically a cross section of the tropical Pacific. And so you're looking only at the equator. It's like you're a deep sea diver and you're looking down from the South Pacific and you're looking toward the equator. And the top horizontal line there is the surface of the ocean, and the bottom horizontal line is 300 meters below the surface of the ocean. And here again, the blues means below average and the reds mean above average. And what we see is a huge stretch of below average temperatures from the central to the eastern Pacific, extending to about 200 meters below depth. And this is important to us because a lot of times the subsurface is essentially our fuel for the surface, and so it's often a precursor. What happens below the surface then have influence on the surface many months later. And this pattern has been fairly stationary now for a couple months now, and it's not going away anytime soon. We have to keep an eye on the warmth that we see in the Western Pacific because that can shift eastward on occasion and end the La Niña. But at this point, there's no evidence of it doing that, at least right now. So this is looking at the atmospheric component. Remember, it's not just the ocean, it's also the atmosphere. So an important indicator for us of La Niña in the tropical Pacific is seeing drier than average conditions around the date line on the equator. And we certainly see that. This is for the month of November. And those browns there are drier conditions, so less rainfall. And then over Indonesia, just north of Australia there, we see increased rainfall. And so this is evidence of this enhanced Walker circulation that I sort of alluded to earlier. So yet another indicator of La Niña, and that we are definitely deep into one. This was shown earlier, but here again is the most updated probabilities. We update this once a month, so these probabilities change. I especially recommend looking at them as we get into the spring because forecasting transitions is very tricky, and springtime months in particular. We have this notion in ENSO research that there's a ENSO spring predictability barrier, and that's because there are real challenges in these models forecasting through the spring. So it gets tricky in there. So definitely keep an eye out on these probabilities. They update each month, but you see very high confidence in La Niña, and then it lowers as we get into March, April, May. It's almost a split between neutral and La Niña. We don't know exactly when it will transition, bit of a coin flip in that region, but by the late spring into summer, we do favor ENSO neutral once again. This is a new tool, and I won't spend too much time on it. It's also just, I mean, to be frank, really hard to look at. I do not love tables of numbers. But there is a lot of information here, and if you're interested in it, we have a blog post, a link up there explaining how we do this. And we do hope to have a new tool that will make this a little bit more user-friendly in the future, so keep your eyes peeled for that. But this is what we have for now, is table of numbers. And so a lot of users ask us, again, using these ENSO metrics in the tropical Pacific, how strong do you expect this to be relative to other La Niñas? And so we have this sort of probabilities that it will exceed certain thresholds. So for instance, in the upcoming seasons, the two upcoming winter seasons here, we think there's about a 45 to 59% chance that Niño 3.4 will be less than -1 degree C. So this is kind of in the middle of the pack of La Niñas. But we do not expect it to be less than -1.5 degrees C, which would be a strong La Niña. So right now we're favoring a moderate strength event, at least insofar as the tropical Pacific Niño 3.4 index goes. All right, so I'm going to transition now and talk a little bit more in terms of impacts. Unfortunately, the information I'm going to give you is a little dated. We have a team of seasonal forecasts who put together these forecasts once a month, and they last put this together on November 18th. I'm actually not on this team at CPC, but they are now busy, and they're putting together the next update, which will be released in 2 days. So check out that website on Thursday and see how things have changed. I expect that it hasn't changed a lot because we are in a La Niña pattern. We kind of know what the drivers are, but it can't hurt to take a look at and see how things have changed. So this is a schematic. I don't love schematics because they really do kind of whitewash the variability that you typically see during La Niñas. But if you just want a general sort of feel for how La Niña impacts North America, this is a decent, if any, graphic. And so La Niñas, by cooling the tropical Pacific Ocean, will impact the North Pacific jet stream in the sense that the jet stream tends to shift to the north. You get a big blocking high pressure over the Gulf of Alaska and North Pacific. And because of that northward shift, the cooler air tends to affect the northern tier of the United States. Wetter conditions are often felt in the Pacific Northwest. Because the jet stream has shifted to the north, the southern tier of the U.S., including the southeast, tends to be drier. It also tends to be warmer. We get a bit of a ridge that builds up in the southeast that shifts the storm track over the Ohio and Tennessee Valley a little bit to the north and to the Great Lakes. So this is a general pattern that we see, but as I will show you in a couple of slides, we do see a lot of variability on this. It is interesting to us. We feel like, at least insofar as October, November, December averages go, we're seeing impacts right now that are fairly consistent with La Niña, at least in terms of precipitation anomalies. So here the greens are wetter conditions and the browns are drier conditions. And so this is taking all 23 La Niña years during the fall since roughly about 1950. And it averages that pattern together. So this is, again, just a composite, an average, a general tendency of what you would expect. And what I find interesting is that for the comparable period, and we now have data through mid-December shown on the bottom right, we see some general features that are consistent with that La Niña. That is, the greens that we see tend to be more across the northern tier of the United States, and the browns, not exclusively, tend to be across the southern tier of the United States with some exceptions. So I think we have been seeing a jet stream pattern that is more or less consistent with La Niña so far this fall. So this is looking now at the winter season, and for us at CPC, the official winter season is December, January, February. So I'm sliding this period forward to DJF, and it's showing this 20 strongest La Niña events since 1950. It's all sorted here. And what I really like about this plot is that it's not a composite, it's not a schematic, so you can see what the La Nina variability is like, and you will see considerable amount of variability when you look at different regions across the United States. But I will say that one of our strongest La Nina signals, and it's not a guarantee, a perfect example is the plot you see on the very top left, where you have wetter conditions over across a large portion of the southeast. But in general, you see a lot more brown in the southeast. And so drier conditions tend to prevail during La Nina winters. It's not a guarantee, but it's certainly a tilt in that direction, which is why having ENSO forecast is useful. A lot of people have asked us what a second dip looks like, and we don't have as many second dips. But here is the subset of winters when you're on a second La Nina winter, and at least based on the subset of 7 La Ninas, yet dry conditions across southeast tends to prevail, not exclusively, but mostly. This is looking at temperature. You may notice temperature is a lot more variable than precipitation anomalies are. ENSO actually impacts precip across the United States more than temperature. And part of that is because variability like the Arctic Oscillation and North Atlantic Oscillation can have a really important influence. We have very limited predictability in how far in advance we can predict the state of the AO and North Atlantic Oscillation. And so often there tends to be a little bit more surprise on the temperature side than the precipitation side. And one thing that's really prevalent, and you see this particularly with the second dip La Nina winters, is that trends have become more important in recent years in the sense that more recent La Ninas tend to be warmer across the United States. And you can see in the southeast in particular, it does appear there's a lot more red during the second dip La Nina winters. These are also tend to be more recent winters. So again, trends are playing a role. You already saw this. This is the DJF Outlook. As the earlier presenter articulated, this is a very La Nina-like pattern. So for temperature, we're expecting above average temperature across much of the United States, except with the exception of the Pacific Northwest and northern tier there. And then for precip, again, we're seeing evidence of that northward shifted jet. And so there's a tilt in the odds. And keep in mind, these are all probabilities. These are not 100% probabilities. These are all casted in terms of like 50 or 60% chance. So make sure that when you're talking to others about this, that you're emphasizing the probabilities. And so that there's a sort of a tilt toward below average precipitation across the southern tier in the southeast, and then again a increased chance of precipitation across the northern tier. And so sort of as I alluded to a few slides ago, a lot of the recent La Nina events have been associated with increased chance of above average temperature across the United States, and largely this is due to trends. So on the left panel there, the top left panel is our La Nina composite with the trends removed, and the middle panel is the trend, and then the bottom panel is the composite plus the trend. And so what you see is that largely the dominance of warmth there is because of the trend. It's not so much because of La Nina. La Ninas tend to bring in cooler temperatures across the northern tier, and that's certainly reflected here, but the warmth is largely trend. For precipitation, one of the more interesting features is that the trend of precipitation looks a lot like La Nina. So when you look at the last like 15 years of precipitation anomalies, you tend to see drier conditions across southern tier and wetter conditions across the northern United States. When you add that to the La Nina composite, you get sort of this amplified La Nina trend. And that's because we have had a prevalence of La Nina conditions over the last 15 years in the aggregate. So that is showing up in this trend pattern. It shows up as more confident probabilities in this precipitation And then I'm going to go ahead and wrap up now. This is the ENSO blog. If you haven't heard of it, we post it twice a month. We've been doing this since 2014, so for some time now. And we put out a post at the same time our ENSO diagnosis discussion is released. So on second Thursday of the month, we have a new post that discusses ENSO. And then we have another post the same month, and we kind of revolve on that. We obviously have a lot of focus on ENSO, but that's not our exclusive focus. We've talked about the polar vortex and other modes of variability like the PNA. So if you're interested in climate and also just having some nice graphics that you can put into your presentations, please go to ENSO blog. Graphics are free to use. It's a government product, so you don't have to worry about copyright. You can use this in your talks. So in summary, there is a La Niña advisory. We expect that to continue, potential transition during the spring. And of course, our impacts are very much informed by La Niña and the trend. Thanks so much for having me. And I guess we'll go ahead now and open this up for some questions.
Great, thank you so much, Michelle. Before we open it up for questions, my name is Meredith Muth. I am a regional coordinator for the drought, for the National Integrated Drought Information System, NOAA's NIDIS program. And this webinar series is brought to you as a collaboration between NOAA's National Weather Service, NIDIS program, and the Southeast Regional Climate Center. We couldn't do it without all the help of these great presenters, our regular presenters, Jeff Dober, Pam Knox, and Sandra Rain, and our guest presenter, especially today, Michelle from the Climate Prediction Center. Drought was mentioned several times. So I wanted to just bring to your attention, there's a couple of additional resources to help you monitor current and predicted drought conditions. One is yesterday, many of you might have received a Southeast drought status update. I will go ahead and include in the recap email a link to that has current conditions, impacts, outlooks, as well as directing you to where you can find more information, especially at the state level. In addition, the U.S. Drought Portal, which is drought.gov, has a wide variety of real-time data and maps from multiple agencies. You can also look at information, including the U.S. Drought Monitor, but other types of drought information at local and sector levels. And you can even sign up for drought alert emails directly related to your zip code. So please check it out in the recap email. We will be sending out a link to the recording, not the slides. We had a question about that. If you do have questions about specific slides, feel free to reach out to me, Meredith Muth. Our next webinar in January 2022. Our first one will be on hourly precipitation trends in the Southeast, and then in February we'll have one on flood climatology. As always, we welcome suggestions on how to improve this webinar series. It's now been going on for about 2.5 years. If you haven't taken the survey that pops up at the end looking for some suggestions, please do, or just reach out to me directly. And with that, I will go ahead and start our Q&A. We have quite a few. So our first question is more of just a very specific one for Sandra. That tropical summary graphic from the National Weather Service, it was a great graphic. Is it available publicly? Sandra?
Yes, it is. NOAA actually put out an article recapping the hurricane season, and I do have that link at the bottom of that slide, and we can send it out in the recap of this as well.
It's great. Sandra, could you also put it in the chat, maybe for the whole audience? That might be nice if you have it. Great. Okay, our next question is for Michelle. I understand that both El Niño and La Niña occurs in the Pacific Ocean, but does anyone know what causes these to occur? Does this have something to do with activities in the Pacific Ocean floor, like the plate movements or oceanic volcanic activities?
Hi, yeah, that's a really good question. It's interesting. So the dynamics of the of ENSO and tropical Pacific are internal to the tropical Pacific. All they require is the ocean and the atmosphere. So to the first order, it does not involve things like plate movements or oceanic volcanoes. With that said, both of those things can potentially impact ENSO. So we do have an ENSO blog post. If you Google ENSO blog and volcanoes, you'll be able to find an old article which talks about how changes in volcanoes and aerosols could actually potentially modify the physics of ENSOs to make El Niños more likely. It's still a very debated topic. It's something that shows up better in the models, and in the real world, we don't have that many examples of large volcanic eruptions that can get into the stratosphere and therefore adjust the dynamics of ENSO. So it's sort of one of those interesting topics that we still don't know a lot about. And then the other thing, the plate movement is an interesting question, because there is obviously an ENSO, an El Niño and La Niña in the tropical Pacific, but why is it in the tropical Pacific? I mean, why isn't it in the tropical Indian Ocean? Why isn't it in the tropical Atlantic? And part of that is because the feedbacks, the interaction between the ocean and the atmosphere, are strongest in the tropical Pacific Ocean because of how big it is. So you can get these instabilities and this sort of lag growth because the tropical Pacific is just so enormous, and it leads to these sort of imbalances that arise in ENSO. And we just don't see that in the Pacific and Indian Ocean to the same extent because they're a lot smaller. Those basins don't get as much instability and growth. So, on some level, ENSO exists because the plates are in the continents are in a configuration that makes the basin large enough to have an ENSO process. So very good questions. So yes, ENSO would exist without plate movements or volcanoes, but it certainly has some interaction with those. Yeah, I don't know if you want me to go ahead now. Oh, perfect. You posted the ENSO blog post. Thank you so much, Sandra. Meredith, do you want to read out the next question?
Yeah, I'll go ahead and do that.
Okay.
And this is related to La Niña as well as in particular related to the Carolinas. I am researching the southeastern region for climate change, air water quality, and urban heat index mapping. The anomalies we are seeing with the La Niña over the 2-year period seem to have shifted the tornado alley regions to the Carolinas. Is this being researched with NOAA, the National Weather Service, and Carolina contributors of citizen scientists?
This is a good question. It's a little out of my wheelhouse. I know that within NOAA, there is certainly some attention being given to possibilities of having this like a seasonal tornado outlook, but it's a really tough problem. And while you can do it experimentally and maybe in research mode, we would want to make sure that our users can benefit from that information and not be misled by it. There is a lot of work being done on trends in tornadoes, and in particular tornado environments. So I have a close collaborator, Michael Tippett at Columbia, who's written a few papers on tornado environments and how those have changed. And with La Niña, and there's also an ENSO blog on La Niña and tornadoes. So go ahead and Google that as well, and you'll get some information. Yeah, so one of the interesting things about not the Carolinas, I can't speak specifically to Carolinas, but our most recent outbreak that we had just a couple days ago is in a location where tornado environments are made more favorable due to La Niña. So there is already speculation. You can see this in media and in papers that outbreak was in part due to La Niña effects. And how that's all changing, well, that's just another topic, but it is certainly an interesting one.
That's a great answer. Is there any other panelist that we have online that wanted to respond If not, I'll move to our last question.
Real quick, Chip Conrad here. I'll just comment that El Nino events, there's a positive association with tornadoes in the deep south, Florida in particular. And so you can think of El Nino and La Niña as sort of shifting where tornadoes occur during the cool season.
That's perfect. I think Chip nailed it there. So again, because La Niña tends to shift the jet north, we might see more outbreaks in the, in the Midwest there. But during El Nino, the jet actually shifts to the south. So maybe closer to the Gulf states and Florida, you would see more outbreaks.
Great. And I think we have time for one more question, and I'll open this up to any of our panelists. Is there any way to predict how wet the next winter may be? So we're talking about the winter of 2022 to 2023. Or is it too soon to predict that far into the future?
This is Pam. I'll take a stab at it. The short answer is no. It's really not possible to predict. Precipitation is caused by a bunch of large-scale and small-scale things happening. The small-scale things like individual thunderstorms, of course, are very hard to predict exactly where they're going to be. Larger-scale things like stationary fronts or things that last a little bit longer and wet a wider area are still hard to predict because the position of those depends on what's going on in the atmosphere all around the North American continent. And so while we have general statistical predictions of what we think is going to happen based on where the jet stream is, as Michelle pointed out, it's really impossible to put any kind of numbers with that at this point.
Yeah, so I agree. I think it's very challenging to make forecasts for that lead time. If push comes to shove, though, and I'm not advocating this necessarily, is that in my presentation we talked about two drivers for this winter, which was ENSO, and at this point we cannot say with any confidence what the state of ENSO would be for the coming winter. But there's also the trends, and so there is that contribution of trends. It's small, so you're not probably going to be able to make a huge bet on it. But in the absence of any information at all, trends is probably the best bet to make.
Great. And with that, looking forward to the trend of ending this on time. 1 minute to spare. Thank you all for joining us today. We wish you all a very safe, healthy, happy, wonderful holiday season. And we'll talk to you in January. We'll talk about precipitation some more, and hopefully we'll get a little bit more in the region. So again, thank you, presenters. Have a wonderful day.
Thank you.
Bye.
Thank you all.